Hi guys, and welcome to the fourth lesson on the topic of logarithms combined with exponentials. Today we're going to be looking at, first of all, a recap of the previous lesson, followed by some more challenging equations with logarithms and exponentials. And then we'll be moving on to finally a rather worded example which we'll have to, first of all, convert into some sort of equation in order to solve it. Now for these three, I'd like you to pause the video and just have a go by yourselves, because this really covers what we went through in the previous lesson, and it's just a recap to prepare you for these questions here. So pause the video and have a go, and then I'll quickly work through the solutions with you afterwards. Okay guys, hopefully you've paused the video and had a go. First of all, we have 10 to the power 3x is equal to 4,000. So for this one, we need to take logarithms of both sides. We then move this 3x to the front using our third law of logarithms. We then divide through by log 10 to get 3x. And so x is now this divided by 3, and x is 1.201 to four significant figures, which is what it specifies here. 7 to the power x is 55. Same principle. Move the x to the front. Divide by log 7. And we get x to be 2.059. And finally, with this one we're looking at using exponentials to get rid of the logarithm. So we do the base to the power of both sides of the equation. The exponential and the log cancel to give us x on the left hand side and 32 on the right hand side, 2 to the power 5, okay? So that covers that. Now we're going to move on to these more challenging examples. Now with these we need to really pay attention, because it often gets a lot more challenging at this point. So we're told to solve log of 2 subtract 3x with base 3 subtract 2 log of x with base 3 equals 2. So here what we need to do is apply a law of logarithms. If we see a subtract or an addition, for example, we should spot that we can apply a law. However, first we have a multiplier of 2, so we're going to have to get rid of this. So we do that by, first of all, moving the 2 as a power of x, so we get x squared. And we can only do that, remember, if the base is consistent. We have the same base for both. And we do in this case, we have 3. Okay, we have 3 for both logarithms. Now we can divide. 2 minus 3x divided by x squared equals 2. And hopefully you can see what we can do now. We can actually do the same thing we did here. We can take exponentials of both sides. If we do the base to the power of both sides of the equation, we then should be able to see that we can eliminate the exponential and the log, but unlike this question, we don't just get x, we're actually left with this whole thing on the left hand side. So we're left with 2 subtract 3x divided by x squared equals 9. Now we rearrange this because we need to solve the equation for x. So we need to make x a subject. Let's first move this x squared to the right hand side. So we get 2 minus 3x equals 9x squared. And then we move the minus 3x across, so we get 9x squared. This minus 3x will become a plus 3x. And this plus 2 will become a minus 2. And this will equal 0. So we have 9x squared plus 3x minus 2 is 0. Now, hopefully you can see how we finish off this question. We have something we can factorise. But how do we factorise this? Well, 3x looks like a value we can put inside the brackets because they multiply together to give us 9x squared. But now we need to think about what goes with that. Well, minus 1 and plus 2 will work because the minus 1 and plus 2 will multiply to give us the minus 2. Plus 6x subtract 3x gives us the plus 3x, and the 9x squared is the 3x times the 3x. And now we make each bracket equal 0. So we get x as a third, and doing the same with this one, x is going to be minus 2 divided by 3 minus 2/3. So as you can see, I've gone through that question rather quickly. The key really is to try and spot what they're looking for. And I know this can be difficult. It's often the case that what they'll do is they'll try and put something in there to try and throw you off. For example, you might think, well, I could move this minus across to become a positive and do something with that and have logs on both sides. Although if you can spot the trick that we can apply a law of logarithms, it just makes the question a lot easier to answer. And usually we'll be asked to take exponentials or inverse an exponential to do a log, for example. But just go through this a few times until you're 100% confident with it. The second one says solve 2 to the power 2x plus 13 times 2 to the power x plus 36 is 0. Okay? In fact, this here should be a minus, okay? So, with that, what we need to do is spot a common factor. Well, what we should notice is that 2 to the power x and 2 to the power 2x are similar, and therefore there is some kind of relationship between the two. 2 to the power 2x we can rewrite as 2 to the power x squared. If you look back to my lesson on the laws of indices, what you should notice is that when we do something to the power of something else, and then to the power of another value, we can just multiply these two together. 2 to the power x all to the power 2 is 2 to the power 2x. And now if we rewrite this whole thing, this is a common factor. And if we have a common factor, it's often easier to write this in some other algebraic form. Now we already have an x, so let's call this y. Let's say y is now equal to 2 to the power of x. And rewrite this using y. Well, if this is y, we now have y squared minus 13, remember this is y, plus 36 is 0. So now we have something we can factorise. And what you might be thinking is, well, how on earth did you know to do that? The answer is I didn't. What you have to do is you have to look at the question and try and realise what they're hinting at you doing, because often with logarithm questions they won't be straightforward. They'll try and in a way hint at you what you need to do. Now with this being in brackets and being very similar to this, they're trying to get you to spot the law of indices. So again, like I said, it's just a case of looking at it for a while and trying to figure out what you need to do. The problem students usually have with logarithms and exponentials is that they often spend up to 10 minutes just trying to figure out how to start the question, and that's a lot of time wasted. What I would suggest is perhaps look at the question for 1 or 2 minutes, and if you're not sure what you need to do, then move on. Come back to the question later on in the exam, if you have time left at the end, for example, because you don't want to be spending too long wasting time trying to figure out what to do when you could be answering a question that's more straightforward later on in the exam. So now we can factorise this. What are we going to get here? Well, we're going to get a minus 9 and a minus 4. Okay? Minus 9 times minus 4 is plus 36. Minus 9y minus 4y is minus 13y. And y squared is y times y. So here we just get y is equal to 9 and y is equal to 4, doing the same as we did here. But now we need to think back. Y is something we made up. It's not really part of the question. Y is just 2 to the power x. We did that so it'd make it easier for us to see we can factorise. Now we need to swap y back for what it is, because we're actually solving this for x. So 2 to the power x is 9 and 2 to the power x is 4. Well, in the case of 2 to the power x is 4, it should be easy to spot that x is 2. 2 to the power of something is 4, or 2 squared is 4. So that's quite easy to solve. But 2 to the power x is 9. We can't see the answer straight away. So what we need to do here is take logarithms of both sides. because this is similar to this question now. Log of 2 to the power x equals log 9. So x log 2 equals log 9. So x is equal to log 9 divided by log 2. So we get a calculator and we do log 9 divided by log 2. We get an answer of 3.17 to 3 significant figures. It doesn't specify how many significant figures we need to do this to, so I'm going to leave it like this. Again, just go through these questions a few times if you're not 100% sure what I've gone through. Often it does take some time to spot what we need to do. The key really, like I said, is not to spend too long on a question. Come back to it at the end of the exam if you're not sure. Now the wordy example says, the radioactivity of a substance decays by 20% per year. The initial level of radioactivity is 400 becquerels. Find the half-life. Now, this is something we could equally get in a physics exam. The half-life just means the time taken for the radioactivity to fall to half of its original value. So what we need to do here is form an equation for the radioactivity at any point. We'll call that R. Well, that's going to be the initial radioactivity multiplied by the decay value. What I mean by that is the amount it goes down by compared to the original. If you think of a percentage being out of 100, then if it's going down by 20% per year, then that just means we're going to have an 80% decrease of 20%, so the percentage we need to use is 80%, which as a decimal is 0.8. And we do that to the power of the time in years. The main thing is to learn this format, because you'll see it in lots of applications, whether it's mechanics, just pure maths, or even whether it's physics. So learn this format. Now, what we need is a half-life, which is a time. We need the time for it to fall to half its original value. So if it's half of its original value, then the radioactivity will be 200. So we put 200 in as our R. And this is still equal to 400 times 0.8 to the power of t. And we're trying to find the half-life, which is a time. So we need to rearrange this for t. Well, 200 divided by 400 equals 0.8 to the power t. So a half equals 0.8 to the power t. And now we should see that we can take logarithms of both sides. Now if we move the t to the front using the third law of logarithms, we get log 0.5 equals t log 0.8. So t is simply log 0.5 divided by log 0.8. So the time is 3.106 years to 4 significant figures. And don't forget the unit of years, okay? So that covers the whole of the topic of logarithms. Now, like I said, this is a difficult topic, and this particularly has been the most challenging lesson because we've looked at exam style questions. If you're not sure, do go through this a few times. I have gone through it quite quickly. But that's the lesson on logarithms. Thanks a lot for watching the video. If you do have any questions, then feel free to leave a comment and I'll try and get back to you as quickly as I can with a response. If you haven't already, please do subscribe to my channel and I'll see you in the next lesson.